Okay, we will do this small section, right? So this is actually I took it from the PDF. I don't have the textbook, right? Hard copy. So the page would be around in page 144. The section is 6.7, right? 6.7, and this is a very short section. So this and the last section for this chapter 6, right? So I will quickly try to give a little explanation of this. In this section, actually the section name is discrete uniform distribution as a model. So as a model means we are going to develop some equations to use for specific situations, and we know what is discrete. Discrete means it is not continuous. We will get the output of the experiment. Now the experiment is we are doing just a random experiment, right? Some activity. So that activity is giving out only discrete values, kind of 1 2 3 4, maybe up to n, but this is an example, right? So discrete, that is only specific outputs, right? And also uniform means, right, the probability of each occurrence is same. So if it is 4, right, obviously if the probability is same, we will get the probability for each one as 1 over 4. For example, now if we have 5 6 numbers, right, 1 2 3 1 2 3 4 5 6 2 3 4 5 6 in a bag. So the output will be 1 2 3 4 5 6, and what is the chance of getting that? Because since all are equal, it should be 1 over 6. So the reason also, all should add up to 1 over 6, right? So each individual, right, should add up to, so we'll say the probability is x plus x plus, in this case x plus x plus x plus 1 2 3 4 5 6 should be 1 1 2 3 4 5 6. So then 6x is equal to 1, x is equal to 1 over 6, right? So simple as that. So if there are only 6 outputs, like that. So if there are n, it would be n. Again, that also I will draw a small graph to chart to explain that. So if this one is 1 2 3, and we don't know how much it is, and finally if it is n, right, if it is n, the probability of getting those outputs will be 1 over n, 1 over n, 1 over n, and 1 over n. Because when you add up all this, right, 1 over n plus 1 over n plus up to 1 over n, so you will have n terms, n into 1 over n, which would be n over n is equal to 1, right? So this is the, I mean, this is simply what we are explaining, right? And now for these kind of situations, so always we should remember the outputs would be from 1 to n, right? Outputs, right, we will say outputs will be 1 to n, right? And also they will have equal probability of 1 over n, right? 1 over. So this is what, now these are the equations we are going to use. So if there are n, the probability of each outcome is 1 over n, and these two only we have to explain, but the proof is not required, right? Proof is not required, but I will try to give a little explanation for only for this ex, so you will get I mean, little comfortable with that, and as a hobby you can try to prove this and this one little later, but just I will give you a little explanation. Now for example, if we have a distribution like x, right, x, so this is uniform distribution, discrete 1 2 3 and up to n, so up to n, and then the probabilities would be, right, probabilities would be 1 over n, 1 over n, 1 over n, up to like this 1 over n. So then what is the expected value, right? Expected value is, we know sigma xpx, these things I have explained in detail, right? And we will use those things here, x into this one. So that would be, we have to apply 1, which it is 1 into 1 over n plus 2 into 1 over n. Always the probability is 1 over n, plus like this up to n into 1 over n. Then when we take the n out, 1 over n out, right? When we take the 1 over n out, we will get 1 plus 2 plus 3 plus up to n. And you know, right, even this Einstein story is there, that the teacher gave the students to, I can, maybe it says Einstein, I can remember, I don't know whether it's another mathematician, right? So teacher gave the children to add up from 1 to 100, and teacher went to do something. So he expected that they will take long time, but in a split of a second, this Einstein added up 1 plus 2 plus 3 plus 4 plus up to 100 in a short way. So, and as O-level students, we know now this is a arithmetic progression, right? Arithmetic sequence. And if you want to add up to 1 over n, we can use this equation, n Sn is equal to n over 2 a plus l, right? N over 2 a plus l. So so n means final one, n over 2, and the first. Now if you take this arithmetic sequence, the initial one term is 1 plus, and the final term is n, that is unknown. Yeah. So we will get n into 1 over n over 2. So that part, right, we can put it here. So we will get 1 over n into, right, n into n plus 1 over 2. So n get cancelled off, and we get our expected value here. So I mean, happily now we can use for now big words, right? Big words for a uniform, discrete, uniform random variable, right? From 1 to n, we can use this equation for expected value. And I'm not going to, I mean, now go for this variance, but the idea is from each value. Now expected value is one, this fellow, no, right? So what we have to do is to get the variance, right? Variance, we can get the what expected value of, right? Expected value of x minus expected value of this fellow whole thing square, and like this. So we can substitute, right? 1 minus now the expected value is this 1 minus n plus 1 over 2 whole thing square, right? And expected, this one is 1 over n plus again 2 minus n plus 1 over 2 whole thing square 1 over n. So I mean expected value of this, right? But this is I mean unnecessary, right? So we will accept this simplification, I mean, because now the exam is closed, and little bit, I mean, some other day we can see what are the methods to prove this. We will assume, right, this equation will give us the what variance, and accept